Do you know someone who has received or donated an organ? Have you ever wondered how the process works? What are the common complications that happen during organ transplantation? And is it possible for humans to be treated using animal organs? Hello, science fans! My name is Shona and I'm your resident Filipino scientist. Today, we talk about the science behind organ transplants. An organ transplant involves removing a healthy organ from one person and surgically placing it in another person. The person who is giving the healthy organ is called the donor, and the person receiving it is called the recipient. Depending on the organ that's being donated, the donor may be dead or alive. The rate of organ donation and transplantation in the Philippines is significantly low. The limited awareness of people about the processes of organ donation and transplantation, together with the limited workforce and facilities, are factors that contribute to this low rate. For example, according to the Philippine Renal Disease Registry, in 2015, there were 32,077 patients on dialysis. And in the same year, only 475 Filipino patients received a kidney transplant. You may be surprised by the types of organs and tissues that can be transplanted. They range from entire organs such as the heart, the lungs, and the kidney, to specialized tissues and structures such as bone marrow, ear structures, or heart valves. When you think of your organs, what do you think of? Your heart, lungs, kidneys, liver? As mentioned, all of those are organs that can be transplanted. And do you ever think about your skin? Did you know that it's an organ too? And it is in fact the very first organ that was transplanted. A Swiss doctor named Jacques-Louis Riverdon performed the first successful skin transplant in 1869. And this surgery paved the way for other types of organ transplants. But it wasn't until 85 years later, in 1954, when the first successful kidney transplant took place. It was performed by Joseph Murray in Boston, Massachusetts. The recipient and the donor were identical twin brothers. And in 1960, the first successful kidney transplant between people who were not twins was successfully performed. And in 1967, 3 more successful organ transplants occurred for the pancreas, the heart, and the liver. To understand the process of an organ transplant, let's look at how kidney transplants work. But wait, why are kidneys so important anyway? Well, for one, they remove waste materials from the body and concentrate them into a liquid called the urine. They also help regulate the amount of substances present inside our cells and all over our blood. And finally, they also help regulate blood pressure. The human body has 2 kidneys, but did you know that it can work with just one?
What?
This means that, unlike other organs, you can receive a kidney from a living donor, and this is called a living donation. But you can also receive a kidney from a person who has passed away. The first portion of organ transplantation is called matching. There are actually 3 tests that are done to evaluate donors. They are blood typing, cross-matching, and HLA testing. The blood test is in fact the first step in a living donation, and it determines if the donor and the recipient are compatible or a match for each other.
Yes!
The rules for blood type in transplantation are the same as they are for blood transfusion. Some blood types can give to others, and some may not. Blood type O is considered the universal donor, which means they can donate blood and any other organ to other people with different blood types. On the other hand, blood type AB is considered the universal recipient, which means they can receive blood and other organs from people with different blood type as them. We'll put a chart over here to see which blood type can donate to which. HLA typing, on the other hand, is also called tissue typing, and HLA stands for Human Leukocyte Antigen. Antigens are unique proteins found in the surface of all of our cells. And out of the 100 different antigens that have been tested, 6 have been found to be most relevant when it comes to organ transplantation. Except in cases of identical twins and some siblings, it is rare to get a 6-antigen match between two people, especially if they are unrelated. You see, a person can make antibodies for another person's HLA antigens. If a recipient has strong antibodies against a donor's HLA antigens, then the risk of rejection is high, and in such instances, the donor is rejected.
No! No!
The cross-match test is a very important part of the living donor workup and is repeated again just before the transplant surgery. Blood from the donor and recipient are mixed, and if the cells of the recipient kill the donor cells, then the cross-match is considered positive. And what this means is the donor and the recipient are incompatible. But if the cross-match is negative, the pair is considered compatible. Once a recipient has been matched with a donor kidney, then an organ transplant can take place. The patients are anesthetized or put to sleep, and the doctor makes a deep incision or cut along the lower abdomen of the patient just beneath the rib cage. The surgeon inspects the donor kidney, leaves behind the faulty organ inside the body, and attaches the new one to the renal artery and veins and via a new ureter to the bladder. Once proper blood flow is observed, as well as the connections to the other parts of the body are considered stable, then the incision or the cut is sewn shut and the transplant is complete. Now, a major issue with organ donation is rejection. Rejection occurs when a recipient's immune system attacks a transplanted organ. Now, your immune system launches an immune response or attack whenever it detects foreign substances or objects in your body. And that's why donor and recipient matching is so important to minimize this from happening to the organ that has recently been transplanted. Rejection can happen in minutes or it can take many years. Doctors closely monitor a patient the first few weeks to months after an organ transplant. Now, the doctor wants to make sure that the patient is not undergoing acute rejection, which is not necessarily cute, because this is the complication that a patient can experience within the first few months of a transplant. To lessen the chances of this, doctors can give patients anti-rejection medication. Thanks to these medications, organ transplants are successful much more often now than in the past. But this weakens the immune system of the patient, and at the same time, it's not a guarantee that the immune system will never harm the transplanted organ in the lifetime of the patient. And so, science has spoken. Organ transplantation is a process that allows donors to provide replacement organs to those who need them. To facilitate this, organ matching is done to make sure that the antigens present in the donor blood and organs won't be severely attacked by the immune system of the host. Because if matching is not done well, then this could lead to the immune system of the recipient to attack the organ that has been transplanted, and this would lead to rejection. At the moment, there are more people who need organ transplants than potential donors. And the sad reality is, for essential organs such as the heart, a recipient will have to wait for a healthy donor to pass away before they can receive the needed organs. But there might be hope in the field of xenotransplantation, which involves the use of animal organs to replace faulty human ones. For the first time, a human has been given a transplant of a pig's heart. David Bennett, 57 years old in Baltimore, Maryland, last January 7, received a genetically modified heart from a pig to minimize the chances of rejection from his body. The donated heart came from a pig developed by the US firm Revivicor. In total, the animal had 10 genes modified. 4 of those were inactivated, including one gene that would result to an aggressive immune response and another one that would cause the pig's heart to continue growing as it is placed in the human's chest. And with this technology, we can potentially provide any type of organ to any patient who would need them. But what do you think? Are you open to the idea of having an animal organ placed inside your body? What potential ethical issues can arise from this process? Please share your ideas in the comment section below. And for a daily dose of science goodness, please follow our social media channels on Facebook and on Instagram. Visit our website also at www.SHE-ensya.com. Thank you very much for joining us today, and I hope to see you around!